Welcome back. Today we are going to continue with yesterday's topic, prime factorization of numbers and finding their HCF and LCM, and this method is called fundamental theorem of arithmetic. Okay. So here we have three numbers. Yesterday we are done with two numbers. Today we are doing with three. Number 12 is given, 15 is given, 21. We have to find the HCF and LCM of all three numbers. Factorize this 12. You can factorize 12 like this, 12 divided by 2. Yesterday we discussed we have to divide with prime numbers only, like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, like this. 12 is divisible by 2, so we write 6 and then divided by 2, it is 3, then 3 by, then we get 1. So how many 2's? 2 square into 3. Like this we have to factorize 15. 15 we have to factorize. When 15 is factorized, 15 is not divisible by 2 because it is not an even number. Divisible by 3, 5, 5, 1. So we can write 3 into 5. There is no 2, so don't write below 2. You have to write below 3. You have to write 3 into 5. 5 is in a new column. And 21 is there. Factorize 21. 21 is divisible by 3. 7. 7 itself is a prime number. Divided by 7. And 3 here. And 7 comes outside this. Okay. 7 is not in the column of 5. 3 is column, 2 is column. And like this you have to make columns. Then it will be very easy for you to understand. Now we have to find the LCM. LCM is product of all primes or prime factors, product of all prime factors with, okay, be careful with its starting name is L, then you have to write its opposite, it is lowest, then you have to write highest powers. Highest powers. Here we have written no common prime factor is not written, only prime factor is written. In 2's, what is the highest power of 2? In 2's, what is the highest power? 2 square. What is the highest power in 3? Here it is 1, 1, 1. Then 3 raised to 1 you have to write. In 5's, what is the highest power? 5 raised to 1. Not only power, the number with the highest power you have to write, the factor with the highest power. 7, it is 7 raised to 1. And then multiply and write 2 square, it is 4. If there is 5, you multiply that 2's power with 5, then it is multiplication will be easy. 4 5s are 20, 7 3s are 21, 21 into 20 it is 420. So LCM is 420. LCM is 420. LCM is 420. HCF we have to find. What is HCF? HCF is also the product of, but here we have to write common prime factors. Common prime factors only we have to take when we are finding HCF. Common prime factors with, here it is starting with H, do the opposite with lowest powers. Only common prime factor. Can you see 2 everywhere? No. So 2 is not taken. 3 is in all the 3 numbers. Then we have to take 3 with the lowest power. Lowest power is also 1. And 5 is only in one number. That is the middle number. 7 is only in the last number. Even if it is there in 2 numbers, we should not take. If there are 3 numbers, all the 3 should have the same factor. Then you have to take the lowest power. So HCF is 3. So you got HCF is 3. Verify that product of LCM into HCF is not equal to product of numbers. What do you have to prove? If there are 3 numbers, LCM into HCF is not equal to product of numbers. If there are 2 numbers, product of LCM and HCF is same as product of the 2 numbers. If there are 2. If there are 3, this rule is wrong. We can verify also. take the LHS, but in textbook it is not asked. If it is asked in the exam, we have to be ready. LHS is LCM into HCF multiply LCM into HCF. LCM is 420 into HCF is 3, multiply it, you get 61260. This is the LHS. Take the RHS. Product of numbers A multiplied by B multiplied by C. All three numbers you multiply. The first number is 12 multiplied by 15 multiplied by 21. Multiply and write. 12 into 15 it is 180. 180 into 21. You can multiply 21 and 18 and put a 0. 18, 36, 8, 7, 3. 3, 7, 8, 0. You can see both results are not equal. So we have to write LCM and HCF is not equal to a product of numbers. There is a relationship between HCF and LCM that is given at the end of the textbook. You can refer it and find it, but it will not be asked in the exams. Okay. For your better understanding, you can refer the hints or the important points of this chapter at the end of this chapter. You can see. Okay. 8, 9 and 25. We can factorize 8 first. I am writing directly. It is 2 cube. And 9 it's 3 square. 25 it is 5 square. Okay. I have written 2's here in one column, 3 is in the other column and 5 is in the other column. And then find HCF. What is HCF? HCF is the product of common prime factors. Common prime factors with lowest power. Here it is highest, but it's lowest we have to write. What is in 2's? Is there any common factor? Common prime factor 2 is not there in 9, not in 25, 3 is not only in middle number, 5 is only in the last number. So there is no common factor, common prime factor. Okay, as there is no common prime factor, but one is a common factor, not common prime factor, one is a common factor for all the numbers. That's why HCF is 1. And LCM is product of prime factors with highest powers. So you can write in 2's what is the highest power? 2 cube, 3 square and 5 square. And you know 2 cube is 8 only and 3 square is 9 only. 5 square is 25. And always you try to multiply like this, an even number with the number ending with 5, then multiplication is easy. 8 into 25 is 200, 200 into 9 it is 180, that is. Okay, here you can see 8 is not a prime number. It has prime factors 2 into 2 into 2 or 2 cube. 9 is not a prime number. 25 is not a prime number. Still its HCF is 1. Okay. Sometimes it happens like this also. Even if all three are prime, it is sure. What we have seen in the previous question, if all three numbers are prime, their HCF will be 1 and LCM will be the product of numbers. LCM will be the product of numbers. This board exam, this question was asked in assertion reasoning. In one of the assertions, it was given that if there are two numbers and they are primes, then their HCF will be what? And their LCM will be what? If they are prime numbers, if A and B are prime, if they are primes, what is their HCF? HCF of A and B will be 1 and LCM of A and B will be A into B. Okay. If three numbers also, the same rule will be followed. If A, B, C are three prime numbers, then also HCF will be 1 and LCM will be product of three numbers. Okay, it will be added like that. Next, it is the fourth question we have already discussed in the previous class. So, Fourth question we are not going to discuss today. So we are going to the fifth question. It is very important. These all questions which are given in the exercise or examples are very important. You have to focus. 6 raised to n, we have to check whether 6 raised to n ends with the digit 0 for any natural number. Okay, we can take some examples. In n's place, we can take any natural number. If it is 6 raised to 1, you know, what is 6 raised to 1? It is 6, it is ending with 6. 6 square, you know, 6 into 6. 6 square means 6 multiplied by 6. What is it? 36. 6 cube, 6 multiplied by 6 multiplied by 6, it is 216. So what you can see through these examples that whatever may be the power of 6, every time it is ending with which digit? It is ending with the digit 6 only. It is the case of 6. Okay, something like that we can take another example, 8 raised to n. Suppose it is 8. What is the power of 8 raised to, even it is 1 power, its result is 8. And 8 square, it is 64. 8 cube, it is 512. Okay, it is 512. So, and 8 raised to 4, when it comes to 8 raised to 4, it gets, again multiplied by 8, it is, then 8 raised to 5, you can continue like this, okay. So, when 8's power is 1, 2, 3, 4, they have different powers, you can see, okay. And again, next will be ending with 8, and next power will be ending with 4, and next power will be ending with 2, and the next power will be ending with 6. So the same 8, 4, 2, 6 will be repeated for 8. But in 6, it is only 1. So its periodicity, it is cyclic, it is happening cyclic. Here periodicity of that cyclicity is 1. Here periodicity of cyclicity is 4. Okay, that you will study in the higher classes. This is I just explained. So what you can understand, in this board exam, one question was asked. In 8 raised to n, will not end with, it will end with which digits we know, 8, 4, 2, 6, it is possible. It will not end with which one? Suppose options are like this, A, B, C, D, or normally D only, I am giving E also. 6 raised to 8 raised to n never ends with which digit? It never ends with 0. Okay, this was an MCQ question in the just concluded board exam. And like that, but in 6 raised to n, it will always end with 6. But our answer should not be written like this. We have to write in a different way. If you write this way, some teachers may consider, some may not. So textbook method we have to follow. So, can you say when a number is ending with 0, or can you say some examples of number ending with 0? If you take any number which is ending with 0 like 10, 20, 30, these all are some numbers ending with 0. These all are coming in whose table? They are coming in the table of 10, or we can say they all are multiples of 10. The numbers ending with 0 all are multiples of 10. Or we can say all are multiples of prime factors. Which prime factors? 10 is not a prime factor. Multiples of which prime factors? 10 is a combination of 2 and 5. Or we can say multiples of 2 and the number should be multiples of both prime factors 2 and 5. Then only it will end with 0. Okay. But in 6 raised to n, if you factorize 6, what do you get when you factorize 6? You will get 2 and 3, then whole raised to n. So 6 raised to n has 2 prime factor maybe many number of times, prime factor 3, this is distributed to this and this. So 6 raised to n has the prime factors 2 and 3 only. But for a number to end with 0, it should be a multiple of 10. 10 means it should be a multiple of both 2 and 5. But in 6 raised to n, can you see 2 prime factor? Yes, you can see 2 prime factor. Can you see 5? Don't say 5 and 3 look alike. So 5, okay, you may write 5 like this. And if you put inside it is 3, if you put outside it is 5, so 3 and 5 are same, don't write. Okay, they are different numbers. So they are different. So can you find the prime factor 5 in 6 raised to n? So in 6 raised to n, which prime factor is absent, which is required to make a multiple of 10 or ending with the digit 0, has no prime factor 5. In 6 raised to n, prime factor 5 is absent. So 6 raised to n will not end with 0. Understood? This is how we have to write. Why 6 raised to n has no prime factor 5? Because 6 raised to n's prime factorization has 2 and 3 only, and it is a unique, it is unique also. So this is because of uniqueness of fundamental theorem of arithmetic. Fundamental theorem of arithmetic. So 6 raised to n will not end with 0. Okay, I will write in the way you are supposed to write. This is roughly I have written. Okay, so I will write here answer, how to write this. This is little bit not like normal mathematical answer we are writing. For a number to end with 0, to end with digit 0, the number should be a multiple of 10 or multiple of both prime factors 2 and 5. But 6 raised to n is equal to 2 into 3 the whole raised to n, 2 raised to n into 3 raised to n has no 5 as prime factor because of, or we can write in detail, because of uniqueness of fundamental theorem of arithmetic. Therefore 6 raised to n will not end with digit 0. 6 raised to n will not end with the digit 0. Okay, it is clear. This question can be asked like this: 15 raised to n cannot end with the digit 0. Why? First statement you have to write the same. For a number to end with the digit 0, it should be a multiple of 10 or it should have the prime factors 2 and 5. Second part of the question, 15 raised to n can be written as 3 into 5 the whole raised to n. It is 3 raised to n into 5 raised to n. 5 is present but which is absent? 2 is absent here. So it is not ending with digit 0. This is how we have to write. But this board exam, one question was there, 15 raised to n into 2 raised to n. We check whether it is ending with 0 or not. 15 raised to n means 3 into 5 the whole raised to n and 2 raised to n. So we can see the prime factor 2 is present, prime factor 5 is present. So both 2 and 5 are present in this product. So it will end with the digit 0. Okay. This question was there in the present board exam. Okay, just concluded board exam. Okay. So we can stop here. So listen students, the present board exam says we should focus each and every point of the chapter very clearly. Don't leave anything like that. Sometimes we feel okay, this is a very small topic, nothing will come out of it. But in board exam, the teachers are making questions in a particular way. Even the smallest or the negligible part you cannot neglect. Every part is important. So don't leave. Okay, you may think that this is very easy, I should not focus. That same thing will happen in exam. The same, which one you neglected, it appears in the exam. Okay, so prepare, focus, attend the classes, even your class, school or anywhere, tuition classes, anywhere, focus. Okay.